Hello, Honors Algebra students. Mr. Lawrence here, and I decided to make a little quick video to help you find your common denominators. I know sometimes it's pretty intuitive for some of you, but as soon as we put variables in there, the intuition kind of goes away. So I thought we would maybe back up a little bit, go back down to elementary school, do a little factoring, more like prime factorization, and see what's really happening when we're finding the common denominator. So let's get down to it. All right. Let's see, first thing I'm going to do is off to the side here, I'm going to write LCD. And I've got this problem, 1/2 plus x over 4 equals 1/6. Now, I'm not actually going to solve this problem. I'm just going to get my common denominator. And the first thing I'm going to do is find the prime factorization of each of my denominators. Well, I know the prime factorization of 2 is just plain old 2 because it's prime. The factorization of 4 is 2 times 2. And the prime factorization of 6 is 2 times 3. Okay. Now, I am going to list factors that need to be represented by my least common denominator. And the cool thing happens when I write a number over here, it gets to represent itself one time in every denominator. So when I write down a number, for example, I know looking at these factors down here, this 2, these two 2's, this 2 and this 3, I know the 3 belongs. So I'm going to put a 3 in here. And when I write it there, I get to underline it every time it shows up in one of the denominator, or once in each denominator. So when I have everything underlined, I'll know I have my LCD. Let's watch and see how this works. Okay, I know the 3, I underline it. There's no 3's in these denominators. I see here I need a 2. Well, I'm going to put a 2. And it's not 32, of course, it's 3 times 2. Well, that means that 2 that I wrote right there can represent him. It can represent one of these 2's, and it can represent him. It can't represent both of those because 2 times 2 is 4, and that's only a 2. Now, are all factors of my denominators represented? No, this 2 here hasn't been underlined. So I'm going to need another 2 over here, and he will take care of him. That means my LCD of this equation is 12. And so the number I'm going to multiply through by to get rid of all my denominators is 12. And when I do that, well, 6 goes into 12 2 times, 4 goes into 12 3 times, and 2 goes into 12 6 times. My new equation becomes 6 plus 3x equals 2. In the interest of time, I'm not going to solve. I'll let you do that. That's pretty simple stuff. Okay, let's look at this example here. So first thing I'm going to do is I'm going to list my LCD. All right, oops, that was strange. Okay, so I need to do the prime factorization of 10. Well, that's going to be 2 times 5. Factorization of 9 is 3 times 3, and the factorization of 15 is 3 times 5. So I'm going to write down a 2. I need a 2 in my LCD. And that 2 can represent him. Any 2's there? No. Any 2's there? Okay, I need a 5 in my LCD. Well, that can represent this 5. No 5's there. And can represent that 5. I need a 3 in my LCD. And that 3 can represent one of those 3's and also represent that 1 3. And then I need one more 3 because this guy isn't represented. Now my entire denominator is represented. If I multiply, I believe my LCD will be 90. So to do this problem, to make it simpler, I would multiply each term by 90. And let's see here. Uh, 10 goes into 90 9 times, so I'm going to have a 9. 9 goes into 90 10 times, so that'll be 10 times x plus 10x. And then 15 goes into 90, I think 6 times. 6 times 1, so I'll have 6. And again, I'm not going to solve it. I'll leave that for you. Okay, how does it work on a problem like this? Well, very much the same way. Oh, good, it's all one thing. Let me slide it down. First thing I'm going to do is go looking for my LCD. Well, in order to do that, I need to do the prime factorization. Well, I'm going to factor. This will factor like that. This is the difference of perfect squares. It'll factor like this. And this one can't be factored. You could say it's prime. Okay, so I go and see. I know I need an x plus 2. That could represent one of these quantities. One there and that one there. I know I need another x plus 2. It's going to represent him. It's going to represent nobody else. Then I need an x minus 2. And so that'll represent that. So I'm going to multiply each and every part of the problem, and I'm going to rewrite this one if you don't mind, by the LCD that I just found. Hold on one second. Put this together. Okay, so I'm going to rewrite this problem, and I'll do it in blue, the factored form. So I have 1 over x plus 2, x plus 2. And then I have x over x plus 2, x minus 2. And that'll equal 1 over x plus 2. Okay, I'm going to multiply them all by x plus 2, x plus 2, x minus 2. And hopefully that's one quantity. It is, because I have to do it in two more places. I have to multiply here and also here. Now this one will be kind of easy because there's only a 1 there, but that's okay. It's hard to see that 1 now, so I'm going to stick it out front. It's just the 1 from the numerator. Don't let that bother you. Okay, so I look here. This and this can cancel. That and that. Now I'm left with 1 times x minus 2. Well, that's just x minus 2. Okay, and this middle one, I get an x plus 2, x minus 2. Oops, wrong one. X minus 2 with an x minus 2. And I have x times x plus 2. Well, that'll be x squared plus 2x. And then finally, over here, this x plus 2 will cancel with that. And x plus 2 times x minus 2 times 1 should be x squared minus 4. And then I can go ahead and solve that. All right, one last example, and then we'll end this video. Go looking for the LCD. I might write it here to give myself a little room. Going to do my factoring, x plus 3, x minus 3. This one's going to factor as x plus 3, x plus 4. And this one's going to factor as just x. It's not going to factor. So my LCD will need an x. It'll need an x plus 4. It'll need an x minus 3. And finally, it'll need an x plus 3. And there we go. Now, again, I'm going to rewrite it just so it looks a little simpler. I'll do 1 over x plus 3, x minus 3, plus x over x plus 3, x minus 4. Oh, should be a plus 4. Sorry about that. And that equals 1 over x. And my LCD is what? X times x plus 4 times x plus 3, x minus 3. And so I'm going to do that in 2 more places, like that, and then like that. Now I'm ready to cancel. All right, so the x plus 3 and the x plus 3, x minus 3, x minus 3. I'm left with 1 times x plus 4. X squared plus 4x. Here, the x plus 3 with that, x plus 4 with that. I'm left with x times x minus 3. Well, this is x squared, and I distribute that x squared. I'm going to get an x cubed minus a 3x squared. And then finally here, the only thing that's going to cancel that is there. And so this numerator is going to look like x plus 4 times x squared minus 9. I just chose to FOIL these because it was easy. And now I got to FOIL these. So I'm going to get an x cubed plus a 4x squared minus a 9x minus 36. And I'll leave the details to you. All I did was FOIL that, and I ended up with that polynomial. All right, like I said, I'm not actually going to solve these. All right, hopefully that helps you out a little bit. Mr. Lawrence signing off. Good night, everybody.